Hello, this is Guy Shavit with Signamax, and in today's video, I'm going to show you how to configure link aggregation or LACP between two C-300 series switches. So first of all, why use link aggregation? What does it mean? Let's say that I have two switches that are interconnected and I want to connect between them between more than one physical link, either for redundancy or for capacity. So let's say I can connect them between them using two links, and I can allow, spanning tree or loopback detection to deal with handle the loop condition. And the way they would do that is disabling one of the links or not forwarding on one of the links, which will solve that problem, and that link will be available for redundancy, but it will not be active, meaning can't be used for capacity, and also there's a convergence time in case that the primary link goes down. With link aggregation, I can have multiple links between them that are active at all times, meaning that I can double, triple, or even up to 8-fold the capacity between the switches. And in case that one of the links fails, the existing links will continue functioning with no downtime at all. So right now I have two C-300 series switches connected here, and I've actually connected between them using two fiber links, so port 9 and 10. But if we look up here, we'll see that port 9 appears to be active in or it just switched over, and I'll explain in a second why. Port 10 is active and port 9 is not. So let's look here at the log and see why. And we're going to see that it says port line is down for reason loopback detection, right? Another way we could see that is if we look here in the interface port, we'll see that it's down for reason LBD. The one thing I mention is if we looked at the other switch in the log, we might very well see a message that says that it is down because of physical disconnection. And the reason is that this switch detected the loop and shut down the port first, so the other switch just saw it saw that it was physically shut down, but doesn't have the reason, if you will. The C-300 series switches have loopback detection enabled on all ports by default. It's great as a default measure to ensure that there are no loops, but it is not as powerful as some of the other features, which is why we saw that periodically it will have to turn that port back on in order to detect the loop again. That's why we saw that it switched from port 9 to 10 being on, because every 30 seconds it has to do that analysis again. And in the meantime, while it's doing it, there is a loop. So what we want to do is enable link aggregation, and we go to interface trunk, and there are actually two options, which we'll explain: static or dynamic. Originally, we'll configure static, and then I'll configure the dynamic and explain the differences. Static, the link aggregation is quite simple, but it is more prone to issues during the configuration itself. While we have configured one side and not the other, we could be in a situation where there's a mismatch, and specifically you could have a type of loop when the one that doesn't have the link aggregation configured yet, and so on. I'd like to start with the remote switch for the reason so that if I lose connection between them, at least that one is configured already. And we're going to go to interface, trunk, static. But ideally, I would be doing this when I have physical access to the switches. It makes it a lot easier. Or another little cheat is disconnecting or turning off one of the two links so that you don't create these kinds of issues while you're doing the configuration. Anyway, we're going to go here to static. We have an option here of configure trunk or general. I want to add a trunk. We're going to see we can have up to 8 trunks on the switch. The number is just a serial number. It doesn't really matter. And we're going to add the first member of that trunk, and then we're going to add another member, the ports 9 and 10. And if we do show members now, we can see that. Now we're going to go to our closer switch and configure the same thing. Okay. Now, it might take a minute or two for them to converge. In the meantime, it's possible, as we can see here, that I lost access to the remote switch. I'm going to have to wait a minute. One of, as I said, the possibilities make it easier sometimes is if I had been doing this when I had a single active link between them, but they as long as I configure them both the same, they will eventually converge. So we're just going to wait. Okay, so that took approximately a minute, and it looks like the connection is back up. Now we see the both ports 9 and 10 are active on both of the switches. And one of the things I wanted to show here is that now, instead of a lot of the statistics and the general information being here under port, it's going to be showing up under the trunk. So we're going to see, for example, the statistics or utilization is going to be for the entire trunk versus for each port. I'm going to run a little bit of traffic here. Unfortunately, the computer that I am using to record this, it has no Ethernet port to laptop with a USB Ethernet adapter, which is limited to only 100 megabits. So that's all the traffic I'm going to get through here. But it is not going to be utilizing a very high percentage of this to get trunk at the moment between the switches. One of the things I want to show is the load balancing. So as I mentioned, automatically the traffic is load balanced between the two ports. But in order to avoid a situation where there's packets that are out of order, the load balancing is done for basically separate streams. By default, you can see that it's source and destination MAC addresses. So if I have all of my traffic is between two computers that have the same, the source and destination MAC, all of that traffic will go through one of the links and will not actually load balance. In a larger network where you have many sources or many destinations, it will load balance approximately, in this case with two links to 50-50. But if you have a situation where, all of your traffic is to one server or something like that, that might not be the case. And again, the reason that it does it this way is because there's no assurances that you won't get out of order packets. You can choose to change the load balancing mode by being just the destination IP address, destination MAC address, or source and destination IP, or the source MAC or source IP, depending on what is the best fit for your network. For most cases, source and destination MAC address makes sense. I can see situations where you might want to pick just the source or just the destination, but using source and destination assures that the most evenly load balance. Again, the only situation where it's not going to load balance is if you really have only a single source and a single destination, or the vast majority of the traffic is that. And we can see if we're looking at our traffic here, if I physically disconnect one of the links, which I just did, the traffic is still going to continue. That's like 9. I plug it back in. I can also disconnect the other one. You might see a bigger drop, but that's just, there we go. As it can, because I'm disconnecting and connecting both of them at the same time. You put it back in. Okay, so that is a static trunk. Now, what is a dynamic trunk? A dynamic trunk is an actual protocol of communication between the two devices that coordinate the trunk. It's a more complicated process between them. The advantage is that you should not have these situations of a mismatch that I mentioned before with the static trunk, right? The static trunk, if I configure one side and the other side is different, wrong, or someone moves one of the cables or something like that, I could cause myself all kinds of troubles. In the dynamic trunk, it will check to see and communicate between them. There's LACP data packets that flow between them. One of the sides will decide to be the master of the, or sometimes you'll see it referred to as active and passive. If they're both supposed to be active, then they do a negotiation between themselves. And that's why you see that in configuration. You're going to see all kinds of things like priorities and keys and so forth. But if we keep it simple, we don't have to change all these defaults. What we will see is, first of all, let me remove the static trunk. So you are not going to be able to configure a static and a dynamic trunk at the same time. And as you see, since I deleted the trunk from the local switch, I have lost access to remote switch. I'm going to physically move my computer over to that switch so I can go ahead and delete that as well. And I'm going to move myself back. Okay, so now we're back to the original configuration where we're probably going to, in a second here, have one of the links up. There we go, and have a loopback detection between them. And we're going to go to dynamic. And we can do here configure aggregator, configure the port, configure the trunk. We can have up to 8 trunks, same as previously. There's no reason to change these admin keys. If you need to, and you have more complicated scenarios where you have multiple different trunks, that's when you're going to want to change these keys between different devices and different switches. What I'm going to do here is I'm just going to enable LACP. Now I can enable it on all the ports. Let's say, for example, I'll enable it on 3 of them. Only 2 of them are connected between them, but I can go ahead and enable it on these 3 for the simple reason that, as I mentioned, there is a negotiation here, and they'll see that that port is not connected to the other device or is. Apply it. We do not need to change any of these priorities and partners and so on. As I said, you will want to do that if you want to be in control of which device has a higher priority or not. We have no reason to do that in this case. It's a very simple configuration, as most will be. Okay, we're going to go to the second switch and configure the same thing. Configure aggregation ports, enable it on 9 and 10, and apply. And now we go back to our original switch that we had here between us. I'm going to, it's going to take it a minute as well to do the whole negotiation process. If we look at ports here, I want to make sure we don't see anything that is shut down right now. I look at the trunk itself. I'm going to see that we have it. It's up. It's operational. Let me look here in our logs. There, we just saw the second port come up. So it's going to be, there's nothing, no loopback detection or anything like that. If we go to our secondary switch, we'll also, as we can see, we've got them both up, and that is the dynamic. The load balancing is going to be the same, statistics history and so forth. And that's basically all you have to do to configure link aggregation, either static or dynamic. One thing to remember is always to save your configuration. Otherwise, when we boot the switch, it's going to come back to previous configuration, and especially if one side is configured differently than the other, that is not going to be good for us. Let's save both of them. There we go. Now configuration is persistent and will remain that way after boot. Thank you very much, and please enjoy the rest of our videos about the C-300 series switch.